Centroid of a triangle is one of the four centers of a triangle and is defined as a point of intersection for three medians of a triangle. Here we are given 3 points as vertices of a triangle, and we will be required to find out the medians and then prove that all of these 3 medians are concurrent and they intersect each other in a common point. Let's get started and label these as A, B and C. If we write down the coordinates of A are 4, -2, 4, -2, coordinates of B are -2, 4, and coordinates of C are 5, 5. Now, because medians will be defined as line segments joining vertex of a triangle to the midpoint of the opposite side of a triangle, then why not we find the midpoints of these sides first? So let's find out these midpoints. And as we have learned in previous lesson that midpoints can be found only by adding x1 plus x2 divided by 2 and y1 plus y2 divided by 2, because the ratio for midpoint is 1, 1, so k1 and k2 really can be taken as 1, 1, and 5 minus 2 will be 3 over 2, so this is 3 over 2, and 5 plus 4 over 2, that would be 9 over 2, and let's name this as point D. And similarly find out midpoint of this side just by approximation. 4 minus 2 would be 2, 2 divided by 2 would be 1, and similarly y is 1 as well, and name this point as E. And if we find midpoint of AC as well, that would be here somewhere, and 5 plus 4, 9 by 2, 9 by 2, and then 5 minus 2 would be 3, this would be 3 by 2, and name this as F. And now we are going to find out the median AD first. The median AD is this, and median BF is going to be this. And if we draw the third median from C, that would be this. And we are going to prove that all these 3 medians intersect in point P, which has coordinates xy. Now we will first find P with respect to AD, and before we start finding the process of coordinates for P, it's very important that you understand that this P intersects AD, or the P is a point which divides the join of AD in ratio 2, 1, means that this, if we divide median into 3 equal parts, P will be at 2/3 of the length from A to D. P is at 2/3 of the length from A to D, means that 2 parts are on this side and 1 is on this side. You could be asked a different question, that find the point of trisection of the medians. This is what is trisection mean, that if we divide AD into 3 equal parts, then find out the point P, which is at 2/3 of the distance from A to D. So now we have 2 as K1 and this is K2, and here if we are finding it with respect to AD, and let's label this as x1, y1, and label this as x2, y2. And now we will find P with respect to median AD. For finding P xy with respect to median AD. If x is equal to k2 x1 plus k1 x2 divided by k1 plus k2, and y would be equal to k2 y1 plus k1 y2 divided by 2. So here we are going to substitute the values for k2 and k1. k2 is equal to 1, so 1 time this is 4 plus 2 times x part of d, that is 3 by 2 over 1 plus 2, and here y is similarly, we are going to find k2 is equal to 1 time y1 is minus 2, so minus 2 plus k1, which is 2 time 9 by 2, and this is dividing 1 plus 2. Here we made this error here, k1, this was k1 plus k2. So this is how we find x and y, and now we are going to find out the values for x and y. This would be 4 plus 3 divided by 3, and y would be equal to minus 2 plus 9, because this 2 will be cancelled with this 2. Minus 2 plus 9 divided by 3, and here x is equal to 4 plus 3 divided by 3. So both x and y, x is equal to 7 over 3 and y is also equal to 7 over 3. Thus the coordinates of point P. So coordinates of P are 7 by 3 for x and 7 by 3 for y. Now we are going to find out P with respect to another median, BF. Here B has coordinates minus 2, 4, and F has coordinates 9 by 2 and 3 by 2. So let's find out now. We will find out. Now we find out P xy with respect to BF, and where B has coordinates, B is the initial point and it has coordinates minus 2, 4, and the end point F has coordinates 9 by 2 and 3 by 2. 9 by 2 and 3 by 2. And this again, if we divide into 3 parts, would have 2 on this side, which is equal to K1, and K2 will be equal to 1 again. So here if we just simply draw a line starting from B to F, that just will make our task easy. So K1 will be equal to, starting from B, this would be K1, which will be equal to 2. K1 is equal to 2 and K2 will be equal to 1. So now let's find out the point P with respect to BF and label B as x1, y1 and F as x2, y2 and x coordinate of point P, xy, is equal to K2 x1 plus K1 x2 over K1 plus K2, and similarly y is equal to K2 y1 plus K1 y2 over K1 plus K2. And now we will be substituting the values. K2 is equal to K2 is equal to 1, so this will be equal to 1 time x1, and x1 is equal to minus 2 plus 2 times 9 by 2 over K1 plus K2. That will put the value. Next step, y is equal to K2 is equal to 1 time 4 plus K1 is 2 times 3 by 2 and divided by K1 plus K2, and we will substitute the values for K1 and K2 in the denominator as well. Therefore this would be equal to minus 2 plus 9, because this 2 will be cancelled with this 2, divided by 1 plus 2, and here we have y equal to 4 plus 3, because this 2 and this 2 will be cancelled, divided by 1 plus 2. So for xy, x is equal to 7 by 3 here, and y is equal to 7 by 3 again. So now P with respect to point P xy with respect to median BF is again 7 by 3 and 7 by 3, and if we were to find out P with respect to the third CE and then take C as starting point, the coordinates of P will be again same. Similarly, P with respect to CE. Similarly, P xy with respect to median CE with respect to median CE E is equal to 7 by 3 and 7 by 3 again. So all the three medians are concurrent. So all three medians intersect in one point, which is called centroid of the triangle ABC. So this question can be asked in variety of ways. Somebody could just ask you, find centroid of the triangle ABC. You know what you got to do. You got to calculate the medians and then their point of concurrency.